Hello, everyone. Welcome back. Today, I want to learn about the slope of a line. So our goals will be to find the slope of the line and then graph a line using the slope and also understand what the slope tells you, what information it gives you. So the slope of a line is given by this formula. So if we have 2 points on a line that go through a line, x1, y1, and x2, y2, then the slope is given by this formula. Also called the change, so y2 minus y1 over x2 minus x1 is also called the letter m. And that's the change in your y's divided by the change in your x's, also called the rise over the run. Let's look over here on the right and let's kind of explain a bit how this works. Okay, so let's say on these sets of axes, let's say you have a point. Here's your x1, here's x2, and here is y1, and here is y2. And you have 2 points. And if you recall, to make a line, you only need 2 points. Let's rename it. Here's x1, y1. This is x2, y2. So imagine a line that goes through these 2 points, a straight line. Then what we can think about is imagine a triangle, a right triangle from here, where this distance, or your hypotenuse, the long side, is this distance between the 2 points. And this distance here, this is your x2 minus x1. And this distance along the y's is your y2 minus y1. And then this ratio of these sides is our slope. Okay. And as we'll see, then basically this fraction of this ratio of these two sides and tells us a lot about the line itself. That's essentially what the slope is graphically. Now, let's look at a few facts about the slope. So, as we said, 2 points are needed to define a line. You only need 2. You can do as many as you want. 2 is all that's required. The slope gives the rate of change in y with respect to x. Okay, so what this is, so for a line y equals x, or this line y gives the rate of change of y, how much y changes so for whatever distance you go on x, it tells us how much y goes up or down. And if you have a straight line, this rate, that change, is always going to be constant. It's not constant for other kinds of graphs, but for a line, it is always constant. A positive slope means the line is going up from left to right. So we see here, it's going up from left to right, so it means it has a positive slope. Then it's going downhill from left to right, has a negative slope. The slope is 0, means our line is horizontal. We'll see that, we'll talk about that later on. Then if it's have a vertical line, that means you have no slope or undefined slope. Now, also 2 lines are parallel. Lines are parallel lines that never touch. They go in the same direction, also have the same slope. And then slopes of lines are perpendicular are negative reciprocals of each other. And one more thing I don't have written here is also that if let's say the magnitude of your slope, how large the number is, as we'll see, indicates the steepness of the slope. So the absolute value of the slope tells the steepness of the slope, whether positive or negative. Let's take a look at a few examples. Let's start. So here on the right. So what we want to do is find the slope of the line that goes through given points. So we'll give 2 points. Then we want to find the slope of the line that goes through those 2 points. So number 1, and let me find my examples. Okay, let's have a line that goes through the points 2, -3, and -7, 1. Okay, now, as far as my formula, it doesn't matter which one I call x1, y1, and x2, y2. You get the same result. I call this one, x1, y1. I call this one x2, y2. Okay, and so from this, then my m my slope is going to be, if I do, and over here we have to be careful with the signs. So to change my y is 1 minus, so it's 1 minus, this minus is part of the formula, 1 minus -3, and then -7 minus 2. Okay. Of course, subtracting a negative gives us a positive. This is 1 plus 3. And this -7 minus 2 is 9. And so our slope is -9, rather. So our slope becomes -4 ninths. Okay. Now let's go down here and actually have a graph. Let me move this to the side just a moment, and we'll graph the line. Now, let me actually write those 2 points again. And what I want to do now is I'm actually going to show that we get the same slope. If I switch my x1 and y1 around, we get the same value. So 2, -3, and -7, 1. This time I'll make this my x2, y2, and make this my x1, y1, and we'll show we get exactly the same thing as long as we do it correctly. So if I do this y minus this y, so -3 minus 1, it means I have to do this x minus this x, x2 minus x1, 2 minus a -7. So my numerator is obviously -4. My denominator is going to be 2 plus 7, which is still, as before, -4 ninths. Okay, and also we graph these 2 points over here on the side. So 2, -3 is right here. And -7, 1 is right here. And so think about the line that goes through these 2 points, and that's its slope. Now, as we can see, we said that this line is going downhill from left to right. It should be negative, and it is. And this magnitude, the absolute value of this, gives the steepness. Okay. So, for example, I had a slope that was larger than this in absolute value, it would be a steeper negative slope. Okay. Let's take a look at another one. All right, number 2. All right, let's see if I can squeeze this grid, another grid in right here. Perhaps I can. I'd like to do another example right below it. Yeah, I can. Good. Number 2, let's take a look at this. This time, my 2 points are going to be 2, -1, and 5, -1. Okay, so 2, -1 is right here, and 5, -1 is right here. Okay, so if we graph that line, you can see it should be just a flat line or horizontal line. Okay, so what that means then, my slope should be, as we said before here, if a horizontal line, your slope should be 0. Let's see if that's the case. All right, so once again, I'm going to call this x1, y1, though it doesn't matter, and x2, y2. So my slope should be, so this y minus this y, so -1 minus a -1. This x minus this x, 5 minus 2. So up top, I have -1 plus 1. Down here, I have 3. And so my numerator, of course, is 0 divided by 3, or that's just 0. Okay? But once again, if you have a 0 slope, it means you have a horizontal line, as we see on the graph. Okay? So anytime your slope is 0, you have a horizontal line. What that means, think if slope is rise over run, there is a run, there's back and forth, but there's no rise, no up and down. Okay? Let's take a look at a third example. Let me move down here. Okay. All right. So number 3, let's say here my 2 points are 3, 5, and the other point is 3, 9. Okay. We can call this my x1, y1. This is my x2, y2. Okay. Now, if I graph both of those, so 3, 5 is right here, and 3, 9 is right here. This is 3, 5. This is 3, 9. But you see, if I connect those two lines, this is going to be a vertical line. All right. Now, as is over here, a vertical line should mean we have undefined slope. So let's take a look at, make sure that happens. So if I do my m once again, if I do this y minus this y, 9 minus 5, I have to do this x minus this x, 3 minus 3. Well, clearly we see on top what we have is going to be 4. Then down here we have 0. And remember, anything divided by 0 is undefined. Okay, so what that means is, once again, this is a vertical line. So vertical lines, any vertical line has undefined slope. And once again, think about slope as rise over run. It means you have no run, no back and forth, but you have only rise, only up and down. Okay, so that's how to find a slope. Now, next thing you want to do is to actually then use the slope to graph. So if we know a point on the line and the slope, we can find another. Remember, for a line, we only need 2 points. So if you know a point on the line and you know the slope of the line, you always find a second point. So here, I want to graph using the slope. Okay, so number 1, let's say we have this. So our point is going to be 0, 1, and our slope, our m, is going to be 3. Okay, now, once again, let's see if I can do another grid right here. Got enough space. Okay. Looks like not quite, but I can. Okay, sorry, give me a minute. I'm having some issues with my. Let me just delete that. There we go. All right, I believe I can kind of squeeze this in right here, and we'll explain how this works. Okay, so once again, my point is I have a point of 0, 1, and my slope is 3. Okay, now we can think of this also as 3, of course, 3 over 1. All right, and since it's 3 over 1, once again, this is my rise over my run. Okay, so how I'm going to do this is I'm going to start at my point, 0, 1, which is right here. Now, since it's 3 over 1, what that means I'm going to do is I'm going to go to the right 1, and then I'm going to go, since it's, so I usually think of any sign, positive or negative, as being my numerator. And this way I'm always going to the right. I'm going to go up 3. 3, that's 1. And this then is a new point on my line. This point here, which is 1, 4. Okay, that's also a point on my line. I can repeat that step once again, going up 1, up 3 to find another point, but I only need 2. And so now I have 2 points on my line. Of course, its original point being 0, 1. Okay, so you can graph using the slope. Let's do one more of those. All right, this time my point I'm starting with is -1, 2, and my slope is going to be, in this case, -4/3. Okay, so once again, let me add my grid. Okay, and so once again, this is my rise over my run. As I usually think of the negative or positive as going with the numerator. So I start out with -1, 2, which is right here. Okay. Now from this point, then, I'm going to go 3 to the right. And since this is negative, I'm going to go down 4. Okay, -4. And that, then by doing that, gives me a new point on my line. And this point is 2, -2. Okay, so now I have another point on my line. We only need 2. Of course, you can do this as many times as you want. We only need 2 points. And then I can then graph my line. Okay, so let's review what we've seen today. So we saw some important facts about the slope, what it tells us. That the slope is a rate of change with y with respect to x, and then for a straight line is always constant. Learn what a positive slope, negative slope means. Also, what a horizontal and what a undefined slope means, and what a horizontal slope means. And understand also that the magnitude of the slope then tells us the steepness of the line. And then we learned also we found we were able to find the slope using the formula. And then we also were able to graph a line using the slope and a point on the line. Thank you. Have a good day.